Hello, so my name is Dr. Sergey Sarkisov, and I will today present a very important theorem in trigonometry. Now, it is going to be called the law of sines. Exactly. So, this is a beautiful trigonometric result that actually does not come about from too extensive of a proof, but at the same time it can be used very extensively. And trigonometry is one of those things where introducing sine, cosine, tangent as functions turns out that it plays a key role in helping us do something that is very attainable versus it not being so if you just did ratios. So let us look at this. Take an arbitrary triangle. Okay, there's a triangle. Could be scaling, could be isosceles, and then could be equilaterally. And then let's take this triangle triangle ABC with angles A, angle B, angle C, right? And then let's call the side length B, and the side length C, opposite angles, and the side length A, opposite angle A, capital angle A, right? And then remember from previous geometry, from earlier classes, we remember what is the area of a triangle? Yeah, it's 1/2 base times side, exactly. Yeah. So let's write the area as 1/2 base B. We don't have height, right? So we put a h for height, just arbitrarily set. Here's a height h. So 1/2 base times height. Now, where does trigonometry play a role in this? We're talking about sine and cosine and tangent. Well, for instance, let's look at where are these functions all relevant for? Usually right triangles, correct? So here's a right triangle. Right, everyone? All right. And look at this. This h, right? What happens? What is sine of the angle C? Anyone? Well, sine angle C for this triangle, right, is opposite, which is h, over hypotenuse, exactly, A. All right. And let's just solve for h. This kind of reminds me of what I did in physics a lot of times, which is decomposing into x and y components, a vector such as velocity. But anyway, so h equals A times sine angle C, right? And that's exactly, so h is A sine angle C, which we know, we know the angles, let's say we know ABC, but we never knew, for example, this height, it's arbitrarily drawn. So let's avoid it. So instead of the area being 1/2 base times side, we're going to put 1/2 base times A sine angle C instead of h, right? So altogether will be 1/2 base times A sine angle C. All right. Now, let us look at all the three possibilities we can express the area in such a way. So, let's look at this now. The area of this triangle, okay, is already, we have found out it's 1/2 A, B, sine angle C, right? Now, anyone else? What is another way, somebody else? What is another way to express the angle, the area of this triangle? Let's look at this. 1/2 AB sine angle C. Well, what if we did this? BC, right? 1/2 BC sine angle A, or we could do 1/2 AC sine angle B. So let's write it. 1/2 BC sine angle B, right? Oops. Let's erase that. 1/2 AC sine angle B, right? And then finally, is also equal to 1/2. What are the other possibilities? Well, the other possibility only is this BC sine angle A, right? So 1/2 BC sine angle A. Okay, great. So we have this, and these are all the same triangle. There's the same triangle, so they're all equal, right? And let me just make it easy for ourselves, and let us divide by. Yeah, you have a question back there? Oh, okay. So yeah, the reason this is notice sine angle C. Well, that means what? That means it's this angle. Sine angle A, it's this one, and sine angle B, it's talking about this angle. So correspondingly to the vertices, okay? So that's why I could have called this theta, alpha, beta, but we're just going to call it ABC. All right. Now, let me divide everything by something that will make things easier for ourselves. So let's do 1/2 ABC. So cancel all this AB stuff. But look at this, and 1/2. What about 1/2 ABC here? Because we have to do the same thing to all of the sides of the equations, right? And 1/2 ABC. All right. Now, what cancels? Well, let me further this along with 1/2 AB cancel, 1/2 AB, we have C left, 1/2 AC, 1/2 AC. And then look at this, 1/2 BC, 1/2 BC. So what is left? Let's see. We have sine angle C over C is equal to sine angle B over B. And finally is equal to sine angle what? Yes, everyone, angle A, yes, angle A over A. This is called the law of sines, and it's a beautiful result in trigonometry that will help us along the way. Thank you.